first off, we need to measure the resistance in our light-dependent resistor. So this is what our light-dependent resistor is. And so we'll hook it up to a multimeter, and then we're going to measure its resistance when it's in normal room light, when it's in shade, if it's in shade, and then we'll use that to base our resistances on later.
This is a pinout diagram of an LM358 dual op-amp chip. The chip contains two op-amps. The second op-amp is not shown or used on this project.
Now we need to calculate the RC resistance. In order to do that, we need to know the resistance when there's light shining on the light-dependent resistance, and that resistance we got was 11 kiloohms. And so when there's light shining on it, we want V2 to be greater than V1. So to calculate that, we just use the voltage divider rule and use our resistances that we already know, and then solve for RC. And when it's dark, we want V2 to be greater than V1, or wait, we want V2 to be less than V1. So we do the same thing, but use our resistance for when the light-dependent resistance was in the dark, which was 23 kiloohms. And then we use the voltage divider rule again to calculate like the range that RC can be. So we got the range for RC to be from 7 kiloohms to 16 kiloohms, and we chose 12.
This figure shows how a transistor can be used to switch on or off the LED light bulb that we made in our previous video. When the jumper wire is applied, the signaling current I signal is allowed to flow into the base of the transistor. In response to this signaling current, the transistor will turn on by closing the path from C to E, thus allowing the much larger 120 milliamp current to power these LEDs. Okay, this is what our final circuit is going to look like. Starting from the top, this gray wire is going to be coming from the collector. This is going to the negative end of our LED bulb. This maroon one is just a ground wire. This other maroon one is also ground. It's running to pin 4 of our op amp. And some op amps this will be a negative voltage, but here it's just going to ground. This white wire at pin 8 is going to positive 12 volts, and this little orange wire is also going to positive 12 volts, but separately. They're not going to the same 12 volts, or else that would mess up the chip, the op amp. And this light dependent resistor is going to be protruding from our final container, and that's what's going to be our sensor in the circuit, turning the LED bulb on and off.